Okay, so we got a question right here. In Lorentz cyclotron, an alternative potential difference was used to accelerate particles to high energy. Explain the significance of expression obtained by Lorentz to the operation of a cyclotron. Now we know that the formula that we obtained was T is equals to 2 pi, right, m by bq. Now we can see, right, we can see basically that if the time like in this expression is basically independent of the radius, which is 2 pi is basically can be known as the radius, and if the radius is independent of the time, right, so we know that v is equals to omega by r, right. If the r is basically independent, means it's constant, right. If you, for example, you take t constant, right, if if t is constant, r is constant as well. So if r is constant, the velocity is also constant, right, the speed is also constant, right. So we can say the time t in the expression is independent of the speed and the radius of the circular path. This is d, right, and it goes into the circular path. This is your basically AC, AC current is connected over here, and your particles basically launch from here, and then they go like this until they just like basically goes out from the d, right. So we can tell from the expression that it is independent of the speed and the radius of the circular path. That means basically the proton, for example the proton, right, it will basically spend the same time whether no matter if the d has a basically has a larger radius, or it doesn't depend on the speed of it as well, how fast it's traveling, because it's independent, right. So it will spend the same time, if you change the radius or not, if you change the speed or not, it will basically spend the same time in each d, right. So between the d's, right. So we use a fixed frequency, for the potential difference, because the potential difference across the gap, this is the gap, right. When you use the correct distance, you increases the speed, which means it goes to a longer radius, right. And you just need to have this fixed frequency in order to basically make the direction be correct, and because of that the speed increases of the particle as each time they cross this basically d, right. I hope I am a little bit clear. I will write the sentence for you as well, so that you can get more clearance of what I'm trying to say, right. So let me write it out. Okay, so I have written the sentence right here. The time t in the expression is independent of the speed and radius of the circular path. That means the charge the charge means the proton, or any charge, basically the proton will spend the same time in the d, even if the circular track is big or the velocity is high, right. It doesn't matter, the time it will spend the same time, right. We use a fixed frequency for the PD, because the PD across the gap will be in correct direction for the particle, you can say for the particle, or to increase the speed of the particle as they cross each time. Now you may ask, like, why I mentioned this point, like we used a fixed frequency for the potential difference because blah 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 next, right. Because as it is said in the first paragraph, right, in the first sentence, in the Lorentz cyclotron, an alternative potential difference was used to accelerate particles to high energy, right. So basically I'm describing how it's been accelerated to high energy or high speed, so because when you have a fixed frequency, right, the potential will make the potential difference between the gap will be in correct direction, meaning it will have, it will increase the speed, it will basically go much faster than before, like much faster, right. so which will, you know, increase the speed of the particle as many times as they cross the, basically they cross the t's, right? So that's why you can see that they are like basically having a small radius, and then they're basically increasing and increasing and increasing, right, until they just basically eject out, you know. So yeah.